Next we have carbon monoxide molecule. Carbon monoxide and CO positive. CO positive, that is formed by the loss of one electron from carbon monoxide molecule. So carbon monoxide molecular orbital electronic configuration is sigma 2s2, sigma star 2s2, pi 2px2, pi 2py2 and sigma 2pz1. Bond order comes out to be 2.5. So this is the diagram for carbon monoxide, and oxygen again, that is lying lower. Orbitals of oxygen are lying low, are less in energy than that of carbon, because electrons they lie more near to oxygen, because oxygen is more electronegative as compared to carbon. ऑक्सीजन जो है वो कार्बन से ज्यादा इलेक्ट्रोनेगेटिव है, तो जो आपके इलेक्ट्रॉन मॉलिक्यूलर जो इलेक्ट्रॉन्स हैं दे विल लाई, वो ज्यादा नियर लाई करते हैं ऑक्सीजन के एज कंपेयर टू कार्बन. और जो आपकी ऑक्सीजन है वो दैट इज वो कम है एनर्जी में एज कंपेयर टू कार्बन, उसके जो ऑर्बिटल्स हैं. सो वी विल ड्रॉ इट लाइक दिस. नाउ sigma 2s2, this is 2s2 2p2, 1s2 2s2 2p2, that is the electronic configuration of carbon, and 1s2 2s2 2p4, that is the electronic configuration of oxygen. So 2s2 2p2 2s2 2p4 for oxygen. This we have done. Now you know, I've told you the reason why the electrons why oxygen is lying lower in energy. Then there is intermixing of the these orbitals. So here what happens, sigma pi 2px, pi 2py and sigma 2pz, they are lower in energy, they become less in energy as compared to sigma star 2s, which is anti-bonding molecular orbital. Sigma star 2s anti-bonding molecular orbital, that becomes higher in energy. So we will this is the only change. So we will fill the anti-bonding में यहाँ कोई भी fill नहीं होगा. So this is how we will fill the molecular orbitals. So sigma 2s2 is there, then we have pi 2px, pi 2py2 and sigma 2pz, and this sigma star 2s2, that is higher in energy when we draw the when we draw the molecular orbital diagram. It becomes higher in energy than these two, because oxygen is more electronegative as compared to carbon. So the electrons they will lie more near, the bonding electrons they all lie more near the oxygen as compared to carbon. Then next we have the structure of carbon monoxide, the electronic configuration for carbon monoxide. Only there will be one change here. The change will be that here in carbon monoxide we will have one electron less. So sigma star 2s 1 will be there instead of sigma star 2s2. So bond order will be 3.5. Then comes your CN molecule. CN molecule electronic configuration 1s2 2s2 2p2. You can see 2s2, this is 2s and 2p, 2s2 2p2, 2s2 2p3, and then we will write the electronic configuration sigma 2s2, sigma star 2s2, pi 2px2, pi 2py2 and sigma 2pz1. So here also nitrogen will lie in will be less in the orbitals of nitrogen will lie lower in energy as compared to that of carbon. Then we will fill the orbitals 2s2 2 star 2s2, pi 2px2, pi 2py2 and sigma 2pz1. This is how it will be filled. So this is molecular orbital diagram for CN. Then if we compare CN if we compare Cn and Cn negative is formed as, it will gain one electron, and Cn negative, so it will have one electron extra. Sigma 2pz, that will have 2 electrons. That is the only difference, that sigma 2pz will have 2 electrons instead of 1 here. Then next we have, if we compare comparison of valence bond and molecular orbital theory, first of all we will do what are the similarities in between these two theories. So both these theories are approximations. Both these theories, they take into account overlapping of atomic orbitals. Then their principle for distribution of electron, that is same. They follow of Boy's rules, Pauli's exclusion principle, Hund's rule of multiplicity. They all are all involved in filling of the orbitals. Then both these theories predict that for bonding the atomic orbitals, there must be overlap. Yes, they have to overlap for bonding, and their symmetry should be appropriate. They should about the molecular axis, so that the overlap is effective. So these are the similarities. Other similarities are that both theories predict concentration of electron density between the nuclei. Yes, both this theory, they predict that there is concentration of electron density between the nuclei, and they account for directional nature of the covalent bond. They suggest that the covalent bond is directional in nature. Then next we have, what are the main points of differences between these two theories. So valence bond theory, it starts with individual atoms and considers interaction between them. And molecular orbital theory, it starts with nuclei of constituent atoms. In valence bond theory, the electrons, they retain their identity, while in molecular orbital theory, the electrons, they lose their identity. That is the main point. Then electrons in molecules are localized as if they are present in isolated atoms. Yes, they do not lose their identity. Then in molecular orbital theory, it treats the nuclei of the molecule as polycentric and then construct the molecular orbitals. They treat them as polycentric, and then the construction of molecular orbitals takes place, means they lose their identity. They are not localized in molecular orbital theory. Then the atoms retain their individual identity, atoms lose their identity. Resonance is integral part of valence bond theory. No resonance concept is here in molecular orbital theory. Then it underestimates ionic term and does not give it much importance. It does not take into account the ionic character of a bond. While molecular orbital theory, it overestimates the contribution of ionic terms in its total wave function. Then a valence bond theory cannot explain the paramagnetic nature of molecular orbital or oxygen molecule, while this molecular orbital theory, it successfully explains the paramagnetic nature of oxygen molecule. So these are the points of differences between the molecular orbital theory and the valence bond theory. With this, your section B of your this covalent bonding, your chapter of covalent bonding is finished as a whole. We have done we have finished the inorganic part of your syllabus. We have finished your inorganic chemistry. It involves two sections, section A and B. So atomic structure we did before, and second chemical bonding and molecular structure we have done. So next we will start with the other paper that I will tell you in the next lecture. Thank you.